Good morning, students. This is next chapter, that is thermodynamics. Thermodynamics means study of heat. That means in this chapter we discuss every times heat, different forms of heat. Thermo means heat, dynamics means flow. That means flow of heat. The branch of science which deals with the process in which heat involved is called thermodynamics. It also discusses about feasibility of reaction. Feasibility means whether the reaction takes place or not. That means based on thermodynamics we can say that whether the reaction takes place or not. Next, here first we should know the definition of system. This is very important point. System means a small part that is chosen for thermodynamic study is called system. A small part in the universe which is chosen for thermodynamic study is called system. Suppose for example, if we do one experiment in chemistry lab, suppose that experiment is a system for us. If I am taking the class in one classroom, so that blackboard is a system for the students. If you are reading book in a class or in a room or in a house, that book is a system for you. So what is the definition of system? Anything which is under observation, under our observation is called system. Then what about surroundings? Other than system is called surrounding. The remaining part of the system in the universe is called surroundings. So system plus surroundings is equal to what? Universe. System plus surroundings is equal to what? Universe. Here one more definition is there, that is boundary. Boundary means the line or the area which separates system from surroundings is called boundary. Suppose I take water in glass of water in a glass up to this level. This is called what? System. This is level of water. This part is what? Surroundings. Now this line is called what? Boundary. So what is the boundary? The line which separates system and surroundings in the universe is called boundary. No need to remember and learn about that definition. Next one is types of system. Here three types of systems are there. First one is open system. Open system means the system in which both heat and matter exchanges is called open system. Suppose take same example. Take water in a glass. After some time, what happened? After 1 hour or 2 hours, what happened? Some amount of water reduces. That means what happened? Matter undergoes exchange with the surroundings. That means here mass exchanges with the surroundings from system. And why mass exchanges takes place? Due to heat. That means heat also exchanges with the surroundings. So this is the best example for open system. So what is the definition of open system? The system in which both matter and heat exchanges. For example, human beings also best example for open system. How can we say that? We are taking food. In that process some heat exchanges takes place along with the mass exchanges. If we are taking food means we are taking some mass. So that is what open system. So what is the example? Water taken in a open vessel. Next, closed system. Closed system means the system in which heat exchange takes place only but not matter. It means in that system only exchange of heat takes place but not mass is called closed system. What is the example? Hot water taken in a closed vessel. What happens if you take hot water in closed vessel? After some time, that hot water becomes cool water, cold water. That hotness becomes cold. So, in that example, heat only exchanges, but not mass. Why mass cannot change? Because we are closing the vessel. That is why it is called closed system. Next one, isolated system. Isolated system means the system in which both heat and matter do not exchange. The system in which both heat and matter do not exchange is called isolated system. For example, take hot water or tea or coffee in thermo flask. That will be considered as isolated system, because if you take them in thermo flask, both matter and heat do not exchange up to certain level, up to certain extent, up to certain time. That means it is actually this system is not applicable in nature. Up to certain level only heat and mass do not exchange, but after some time heat and mass exchanges definitely. You know that very well. So that such type of systems are called isolated system. So what is the definition of isolated system? The system in which both heat and matter do not exchange is called isolated system. Example is what? Hot water taken in a thermo flask. Next one, types of properties. These are very important for 1 mark. First property is extensive, second one is intensive. Extensive property means the properties which depend on amount of the substance are called extensive properties. The properties which depend on amount of the substance are called extensive properties. For example, mass, volume, heat capacity, enthalpy. We discuss about these points later. Until then, you just remember about them. Mass, volume. These are the best examples for extensive system. Suppose I take 2 glasses. In this glass I pour 1 liter water. Here I pour 2 liters water. So what happened? Compared to 1 liter, 2 liter is having more volume. Compared to here mass is also more. Why? If volume is more, automatically mass also will be more. That means this mass and volume depends on what? Quantity. So that is called what? Extensive properties. Then what about intensive? Extensive means it depends on mass. Intensive means it does not depend on mass. That means these are independent on amount of the substance. The properties do not depend on amount of the substance is called intensive properties. For example, density, pressure, temperature, specific heat, etc. How can we say that about density? That density is intensive property. See, this is 1 liter water. This is 2 liter water. What is the definition for density? Density is equal to mass per unit volume. Per unit volume. Suppose, come to this one. Here 1 liter. Here suppose density is 1.1 gram per cc or ml. Because we have to consider density per unit level. Here also both are waters. This is 1 liter water, this is 2 liters water. Here also same density will be there. 1 point, even amount is more or less, because density definition is what? Mass per unit volume. Per unit volume. Unit volume means either it is a liter, it will be in liters or milliliters, whatever it may be. So that density is intensive property. That means it does not depend on amount of the substance. Similarly, temperature also. We know that 1 liter water having suppose 27 degrees centigrade. Suppose automatically two letters also having same temperature, they also exhibit same temperature. That means temperature, density, pressure also, because pressure definition is what? Pressure means force per unit area. Unit area, that means we have to consider force per unit area only. So that pressure is also comes under which category? Intensive property. That is about types of properties. About specific heat we will discuss later. Next, types of process. These are also very very important. Isothermal process. We got already about isotherms in states of matter. Isotherm means what? Temperature constant. Isothermal process means entire the process temperature is constant. That is called isothermal process. If temperature constant, automatically change in temperature nothing but delta T. Delta T means what? Change in temperature, that will be 0. And also delta E also will be 0. Here new term has come. What is that new term? Change in internal energy. Change in internal energy. Internal energy. Actually internal energy is a term which depends on temperature. Internal energy depends on temperature. Here temperature is constant, automatically the internal energy also will be constant. If it is constant, then change in internal energy will be 0. So in that process, both change in temperature and change in internal energy both will be 0. Next, adiabatic process. Adiabatic process means entire the process heat is constant. That means heat cannot transfer from system to surrounding and from surrounding to system. In that process also Q, heat is represented by Q. Q is 0, nothing but delta Q is also 0. Next, isobaric. Isobaric means what? Pressure constant. So what is the isobaric process? The process in which pressure remains constant. If a pressure constant, automatically change in pressure will be 0. Isochorous means what? Volume constant. Isochoric process means the process in which volume remains constant. If volume constant, then change in volume, that means delta V will be 0. Next, irreversible process. Irreversible process means the process takes place from system to either from system to surroundings or from surroundings to system. Nothing but in either forward reaction or backward reaction. What is forward reaction? What is backward reaction? Suppose reactants, if reactants are converted into products, that is forward reaction. If products are converted into reactants, that is backward reaction. That is in that process, in that irreversible process, either this process should takes place or this process should takes place. Either forward reaction or backward reaction. System to surroundings or from surroundings to system. That process is called irreversible process. All natural process are irreversible. All natural process. For example, take water. Water always flows from higher level to lower level by itself. It cannot flow from lower level to higher level by itself. It can flow from lower level to higher level by using machines, by using pumps. But by itself, it can flow from higher level to lower level. That is what? Natural process. Next, one more example. Heat always flows from hot body to cold body. It cannot flow from cold body to hot body by itself. Similarly, air flows from high pressure region to low pressure region. It cannot flow from low pressure region to high pressure region by itself. So all these are what? Natural process. All natural process are what? Irreversible process. That's it. Next one. Reversible process. Irreversible means one direction. Reversible means two directions. That means from system to surroundings or from surroundings to system. Nothing but both forward and backward. That is called reversible. Next, in reversible process, delta H is 0. This is very very important point. Suppose in every reaction, suppose I take this reaction, N2 plus 3H2 gives rise to 2NH3. For this reaction, this much amount of heat will be released. When this reaction takes place, this much amount of energy releases. Suppose when backward reaction takes place, then this much amount of heat absorbs. That means what? Plus 92. When backward reaction, this is for backward reaction, this is the heat for backward reaction, this is the heat for forward reaction. Reversible means forward plus backward, that means minus 92 plus 92, that means how much? Delta H is equal to 0. So in every reversible reaction, delta H will be 0. That is a very important point. Next one, cyclic process. Cyclic process means, see, this is the example. See, this is the starting point. This starting point can be obtained by number of steps. See, A to B, B to C, C to D, again D to A. That means this initial stage is obtained after several steps, after number of operations. That is called what? Cyclic process. In that cyclic process, delta H will be 0. If delta H will be 0, automatically in that process delta E is also 0. E means internal energy. In this process, internal energy also constant throughout the process, because initial stage is obtained again after some steps, after number of operations, initial stage is obtained. That means initial stage and final stage will be same. If initial stage and final stages will be same, then internal energy will be constant. If internal energy will be constant, automatically delta E will be 0. So what is the point? Delta H is 0, delta E is also 0. If delta H and delta E both are 0, then all these will be 0. All these means Q, delta G and delta S will be 0. This is all about types of process.